All right, welcome to The Explainer. Today, we're jumping right into one of the most talked about technologies out there, generative AI. We're going to cut through the noise to really see what it is, how it works, and most importantly, how you can use it to actually make yourself smarter, not just find a quick answer. So, for years, right, we've thought of AI as this thing that predicts stuff. It forecasts the weather, it spots our grammar mistakes, maybe recommends a movie. But the real game changer, the thing that has everyone buzzing, it all starts with this one question. Can an artificial intelligence actually create something totally new? Well, the answer to that question really splits the world of AI into two big camps. On one side, you've got predictive AI. Think of it like a detective. It looks at all the existing clues and data to point to a specific outcome, like, yep, this email is definitely spam. But generative AI, that's a whole different ballgame. It's not a detective, it's an artist. It doesn't just predict, it makes brand new content, stuff that has literally never existed before. Okay, so how in the world does a machine do that? How does it go from just predicting stuff to actually creating? To get it, we really need to peek under the hood and, look inside the AI brain. At the very core of any AI, you've got what's called a model. And I want you to just forget any image of a physical brain with wires and stuff. A model is, well, it's like a brain made of pure mathematics. It's this huge, complex structure that's designed to do one thing really, really well. Find and copy the patterns it sees in massive amounts of data. Now, what happens when you take one of these math brains and you feed it just a ridiculous amount of text? I'm talking pretty much the entire internet, every book, every article. When you do that, you get what we call a large language model, or an LLM for short. And yep, these are the powerhouses behind the tools we all know, like ChatGPT and Gemini. So what is it that gives these models their firepower? What makes one a creative genius and another one, well, kind of dumb? It really all boils down to one key idea: parameters. And just to give you a sense of the scale we're talking about here, the famous GPT-3 model, which really kicked off this whole craze, was built with 175 billion parameters. No, that is not a typo. 175 billion. So what even is a parameter, right? The best way to think about it is like this. Imagine each parameter is a tiny little knob that the model gets to tune and adjust while it's learning. With billions of these knobs, it can capture an unbelievable amount of detail and nuance from all that data. This is what basically becomes the model's knowledge, its long-term memory. Okay, so if parameters are the long-term memory, think of the context window as its short-term memory. It's all about how much information, your conversation, the document you uploaded, that the model can keep in its head at one time to understand what you're actually asking for. And this, right here, just shows you the absolutely insane speed of progress. I mean, just a couple of years ago, a model could maybe remember a few pages of a document. But look at this jump. Models like Gemini 1.5 can process 1 million tokens. That's not just a book, that's an entire 7-book fantasy series it can hold in its memory all at once. It's wild. All right, so we've got these super powerful models. They have these massive memories. But how does that turn from a bunch of code into something useful, something you can actually chat with? So when developers want to build with this tech, they basically have two main paths they can take. They can use what are called closed models, like GPT-4. These are proprietary, right? They're owned and controlled by a company. Or they can go with open models, like Llama or Mistral, where the actual code is out there for everyone to see, to mess with, and to build on. But here's the thing that has really, truly poured gasoline on the AI fire. For a developer, someone writing code, asking one of the most powerful AIs on the planet a question, well, the code for that looks almost exactly the same as the code for something super simple, like asking for the weather. It's that easy. And that is why we're seeing this absolute explosion of AI tools everywhere. All right. This brings us to what I think is the most important part of this whole explainer. Let's stop talking about the what and the how, and let's talk about you. How can you use this incredible technology not just to get easy answers, but to actually make yourself smarter? You really have to think of it like your own personal tutor, one that's available 24/7. You can use it to brainstorm ideas when you're stuck. You can have it whip up a quick summary of a super dense article, or, and this is a great one, you can have it act like a teacher and create practice questions for you to prepare for an exam. But, and this is a really big but, with all this new power comes a huge, huge trap. And honestly, a lot of people are falling right into it. So here's the trap. Your brain, it doesn't learn when things are easy. It learns when it has to work, when it has to struggle to find an answer. That struggle, that effort, that's what actually forges the connections in your brain and creates real lasting memory. So when you just copy an answer from an AI, you're completely skipping that process. You're basically outsourcing the thinking. The real key is to use AI as a guide, to be a partner in your thinking, not a crutch that does the thinking for you. And this really gets out of fundamental truth, doesn't it? The point of going to university, or just learning anything really, isn't to just fill your head with facts like a walking encyclopedia. It's about learning how to think. It's about learning how to wrestle with a problem all by yourself. And that leaves us with a really big question to chew on. As these AI tools get better and better, even superhuman, at just giving us answers, our most valuable skill, the thing that makes us human, is going to change. It won't be about having the answer anymore. It'll be about having the curiosity, the creativity, and the critical mind to ask the right questions in the first place.
Have you ever felt like you're just drowning in information? Like you really need to get up to speed on something complex, fast, but wading through endless articles and lectures just isn't feasible. You just want the essentials, right?
Yeah.
The core ideas, the key terms, maybe those few surprising bits that actually stick, tailored for what you need. Well, if that sounds familiar, you are definitely in the right place today. We're taking a deep dive into a field that's, well, it's more than just buzzwords. It's fundamentally changing how we deal with tech and info. Generative AI. Okay, let's try and unpack this fascinating world, starting with a really basic question, actually. What kind of problems is AI even good at solving? Because, I mean, not everything needs AI, does it?
No, that's a really crucial point to start with. Absolutely. Not all problems are, well, made equal for tech. Think about calculating grades, right? Or employee salaries, even launching rockets. These are about precise calculations, complex engineering maybe, but with fixed rules. Traditional computing, it loves that stuff, handles it perfectly.
Right. So a super fast calculator, incredibly accurate.
Right.
But you're saying there's this whole other class of problems where that old approach it just doesn't cut it.
Exactly. Think about trying to predict, say, vegetable prices next week, or converting really messy handwriting into clean text, or checking grammar with all its little exceptions and nuances, or, and this is maybe the most surprising one, generating totally new music or art. Those are the tasks where the old systems struggle. They involve ambiguity, subtle patterns, maybe even a kind of creativity that fixed rules just can't handle. That's really where AI, machine learning, that's where it shines.
And that distinction, that leads us right to what generative AI actually is. We hear AI thrown around all the time. It's this huge umbrella term.
Yeah.
But it's really important to separate generative AI from what we might call predictive AI, or sometimes discriminative AI. So let's say you have a massive photo library. You want an AI to just tell you, does this picture have a cat in it or a dog? That's predictive AI. It's aiming for a specific outcome, right? A classification. It's basically saying, yep, cat, or nope, not a dog.
Precisely. Predictive AI is all about forecasting or categorizing, recommending things. It's answering a specific question with a specific, often kind of binary or maybe numerical outcome. Predicting a stock price, maybe classifying a medical image, recommending a movie based on what you watched before. It's analytical.
Okay. But generative AI, it flips that completely. Instead of just analyzing what's already there, it creates something new. Imagine asking an AI, design a picture of a cat that's never existed, or write a poem like Shakespeare would, or compose some original jazz. That's generative AI. It's focused on creating totally brand new content. So maybe an analogy helps. Predictive AI is like a really skilled art critic. It can tell you if a painting is a masterpiece or a fake. Generative AI, though, is more like the painter, creating a totally new, original work from a blank canvas. Both deal with art, but the goal is fundamentally different.
And that shift, from analysis to synthesis, that's what's truly revolutionary here. It's not just finding patterns, it's extending them, creating something novel, something coherent.
Okay, so we know what they are now. But the next logical question is, how do they actually do it? How do these things get so smart and, well, generate content? It starts with something called neural networks. You can sort of think of them as the underlying brain made of math for AI. They're basically these interconnected nodes, a bit like neurons in our brain, but they're just incredibly good at finding really complex patterns in data. Now, when we're talking about generating text specifically, we're usually talking about language models. And neural networks are absolutely crucial for them. They're the engine, really.
That's right. A language model is basically a system that's been trained to understand, process, and crucially, generate human language. And the real seismic shift, the game changer in this space, happened back in 2017. Google introduced the transformer architecture. It was in that research paper, Attention is All You Need. Before transformers, models kind of processed words one by one, sequentially, which made it really hard for them to grasp the full meaning of long sentences or complex ideas.
So it was like trying to read a book, one word at a time. And by the time you got to the end of the sentence, you'd forgotten the beginning.
Pretty much, yeah. Transformers solved this with a mechanism called self-attention. This let the model look at all the words in a sentence at the same time and figure out which ones were most relevant to each other, no matter where they were positioned. That fundamental change allowed them to understand much longer chunks of text, much more complex relationships between words. It really revolutionized how these models learn and generate text, paved the way for what we have now.
And within that architecture, we see a couple of main types of models emerging, right? There are autoregressive models. You might know these from things like ChatGPT. They work by predicting the next word or token in a sequence, building text piece by piece, always looking back. Then you have auto-encoding models, like Gemini uses this approach. They learn by sort of reconstructing corrupted input, filling in the blanks, maybe restoring missing parts of a sequence.
And yeah, thanks to these big leaps, we're seeing some incredibly powerful modern large language models, LLMs, popping up. The sources we looked at mentioned some impressive ones like DeepSeek R1, Kuwen 2.5 Max, obviously ChatGPT, which everyone knows, and Grok 3. These are all built on these core ideas, and they're just pushing the limits of what Gen AI can do, showing amazing fluency.
Okay, this is where it gets really interesting, I think.
Yeah.
Understanding the jargon, the vocabulary behind these models, because you hear all these terms, foundation models, LLMs, multimodal, it can sound like alphabet soup. But there's actually a pretty clear hierarchy. Once you get it, it makes sense. So at the top, you have what are called foundation models. Think of these as huge pre-trained general purpose models like GPT, PaLM, Llama. They're designed to be adaptable, like a versatile base for lots of different tasks.
And then large language models, LLMs, they're a type of foundation model, specifically for text. So GPT-4, Claude, Gemini, they're all about understanding and generating language. Text in, text out, mostly. But beyond that, we're now seeing the rise of multimodal models, like GPT-4o, the newer Gemini versions, Claude 3. These guys can handle more than just text. They can process images, audio, even video, and generate outputs across these different formats, too. It's really impressive seeing them connect different senses, so to speak.
Right. And one term you hear constantly, especially when people talk about how big a model is parameters. What exactly are parameters?
Okay, so parameters are essentially the parts of the model that get learned during training. You can think of them as the knobs and dials the AI adjusts to get better at its task, or maybe like the connections in that huge network.
And the scale is just mind-blowing, right?
Yeah.
A small model might have, 10 million parameters?
Yeah, something like that. But then you look at GPT-3, which came out a few years ago, 175 billion parameters. And it's not just a bigger number for the sake of it. It really dictates the model's capacity, its ability to learn those super intricate patterns, to store vast amounts of information, essentially knowledge, from its training data. More parameters generally means it's more capable, more nuanced. But, and this is the kicker, that huge scale is also why training these things is incredibly expensive. It needs unbelievable amounts of energy, massive computing power. It's a real trade-off. Amazing intelligence, but at a, frankly, unprecedented cost.
That's a really vital point about the economics behind it all. Okay, another key term, context window. What's that about?
Right, the context window. Think of it as the model's short-term memory for a specific conversation or task. It's the amount of text, the input you give it, that it can actually read and understand at one time. It's measured in tokens. Tokens are like the basic units, the model processes. Not always whole words, sometimes parts of words, punctuation. It's how it handles language efficiently.
So the bigger the context window, the more information it can juggle in its head during our conversation.
Exactly. It's incredibly important. Crucial for having long, coherent conversations where it remembers what you said pages ago, or for summarizing really long documents without losing the main points, or for complex reasoning tasks, coding tasks, where it needs to see the big picture.
And the size is very massively, you mentioned.
Oh, hugely. For comparison, like GPT 3.5, maybe around 4,000 tokens. Okay, decent. GPT-4 Turbo jumped way up to 128,000 tokens. Big difference. And now, some newer models are pushing way beyond that. Gemini 1.5 can apparently handle 1 million tokens. Llama May 4, maybe even 10 million.
10 million tokens. That's just, it's hard to even comprehend holding that much information actively in mind at once. Feels like science fiction territory.
It really does. And behind all these capabilities, there's the whole model life cycle, how these things are actually built and deployed. It starts with training. That's how the model learns. You feed it just immense amounts of data, like almost the entire internet's text. You give it examples like the sky is B and tell it the right answer is blue, and it adjusts all those billions of parameters, those knobs, to make fewer mistakes next time. But yeah, it's incredibly expensive. Needs those massive data sets, powerful hardware GPUs, TPUs, and tons of computation time. Days, weeks, months even. Just getting the data ready is a huge job.
Okay, so after that massive, expensive training phase, we get to inference. What's that?
Inference is simply using the trained model, asking it questions, getting predictions, generating text, like asking, what's the capital of France? And it giving you Paris. It's much, much faster than training. And it can be done on all sorts of devices, sometimes even your phone, because it's just applying what it learned, not learning anymore.
Got it. And then there are other stages too, right? Like fine-tuning.
Yes, fine-tuning. This is really interesting. You take a big general pre-trained model and you give it more training, but on a much smaller specific data set. This is how you turn a generalist into a specialist. Maybe make a general LLM into a really accurate medical Q&A bot by fine-tuning it just on medical texts. It dramatically boosts performance for specific tasks or lets you customize its behavior.
Okay. And distillation. Sounds like making whiskey.
Sort of. Distillation is a clever trick. You compress a big, powerful teacher model into a smaller, leaner student model. The goal is to get a model that's faster, lighter, cheaper to run, maybe for devices with less power, like phones. DistillBert, TinyBert are examples. You keep most of the performance, but in a smaller package.
Which leads nicely into small language models, or SLMs.
Exactly. SLMs are basically scaled-down LLMs optimized for speed and efficiency. Think TinyLlama, Mistral 7B, Gemma 2B, Phi 2. They're great for quick tasks running locally or in places where you don't have massive servers. You trade some capability for speed and lower cost.
Right, so we've covered the what and the how. Now let's shift gears a bit. Where does the rubber meet the road? How are these things actually being used and developed in the real world? One really exciting area is reasoning models. These sound different. They're LLMs trained specifically for complex reasoning.
Yes, this is a fascinating frontier. They're often trained using reinforcement learning techniques to get better at multi-step, complex thought processes. What's really unique about them, or the claim at least, is that they think before they answer. So instead of just spitting out a response directly, they generate a kind of internal chain of thought, a sequence of reasoning steps before they give you the final answer. This makes them potentially much better at tricky problem-solving, coding, scientific reasoning, planning complex tasks. We're seeing names like OpenAI O1, DeepThink R1, Gemini 1.5 Deep Research, Grok 3 Deep Search, Qwen 2.5 Max Thinking, all aiming for this deeper reasoning capability, simulating deliberation.
That sounds like a huge step beyond just predicting the next word. It really feels like they're grappling with the problem more deeply. Now, for developers actually building apps using these LLMs, the way they interact with them is quite different from a, let's say, normal API call, isn't it? Like if I call a weather API, I send a very specific request, temperature, Colombo, Tuesday. I get back structured data, like a number. Very predictable.
Absolutely. That's a standard API call. But calling an LLM, say, via OpenAI's API, it's much more fluid. You might send a natural language prompt like, hey, can you explain what partly cloudy with a chance of showers actually means for my picnic? And instead of structured data, you get back a natural language explanation that the model generates right then and there. It's not just pulling a definition, it's creating an answer tailored to your question in context. It's a totally different kind of interaction, much more conversational, generative on both sides.
That makes perfect sense. Another big distinction people talk about is open versus closed models. Can you break that down?
Sure. So open models like Llama from Meta, Mistral, Falcon, GPTJ, their weights, the learned parameters, and often the code are publicly available. This fosters a community approach. People can tinker, customize, build on them. It leads to a lot of transparency and innovation from everywhere.
Sounds great for experimentation.
It is. But then you have closed models. Think GPT-4 from OpenAI, Claude from Anthropic, Gemini from Google, Grok from xAI. These are proprietary. The companies control access. The models are often trained on huge private data sets. They keep the inner workings, well, closed.
So what are the main trade-offs there for someone building something, beyond just the cost, maybe?
That's the key question. With open models, you get incredible flexibility. You can fine-tune them deeply, run them on your own servers. You know exactly what's going on inside, mostly. Plus, there's a huge community helping out. The downside, you might need to manage the infrastructure yourself, which can be complex, and maybe the absolute cutting-edge performance takes longer to trickle down compared to the big, well-funded closed models. With closed models, you often get state-of-the-art performance right out of the box. It's a managed service, easier to get started maybe, but you trade away control, transparency, and sometimes the ability to really customize the core model behavior for your specific niche. It often boils down to control versus convenience and cutting-edge access.
And speaking of open source and community, we absolutely have had to mention Hugging Face. They seem absolutely central to the whole AI, especially the NLP world right now.
Oh, massively. Hugging Face is, it's hard to overstate their importance. They're an open source platform, essentially a central hub. They host thousands of pre-trained models, vast data sets, and provide amazing tools, libraries to work with text, images, audio, everything.
So why have they become so crucial?
Well, they basically democratize access to really powerful AI. Their Transformers library gives you easy access to tons of top models. The Model Hub, thousands of models ready to download and use. Data sets, same thing. They even have things like an inference API for quick testing in the cloud and spaces for hosting simple ML apps. The benefit is huge. You don't need to train these giant models from scratch yourself, which saves incredible amounts of time and money. You tap into this massive active community. It supports all the major tools like PyTorch, TensorFlow. It's super easy to integrate. Like, you can literally load a pipeline for summarizing text in like 3 lines of code and just start using it. It empowers everyone, not just the big tech labs.
Okay, fantastic overview. Now let's bring it back to you, the listener, because we've talked a lot about the tech, but how can this actually be a tool for your own learning?
Yeah.
Because it really can be if you use it smartly.
Absolutely. Think about using a chatbot, maybe like ChatGPT, but in a Socratic way. Ask it questions that force you to think deeper, rather than just asking for the answer. It can be like a personalized AI tutor.
Yeah, or use it for brainstorming. If you're stuck on an essay or a project, bounce ideas off it.
Exactly. Or ask it to generate FAQs about a complex topic you're trying to learn. Or create summaries of dense readings to get the main points quickly. It can even help with exam prep. Ask it to generate practice questions on a topic, then you try to answer them. It can quiz you.
But, and this is a really, really important but, we have to talk about the danger zone. Why you shouldn't just use ChatGPT or any AI just to get the answers spoon-fed to you. It's such an easy trap.
This really boils down to some basic cognitive science, how our brains actually learn. Your brain learns best when it works hard, when it struggles a bit, when it has to actively retrieve information, process it, connect it to what you already know. When you just ask the AI for the answer and copy it down, your brain activity actually drops significantly. You're outsourcing the thinking. That effort, that struggle, that's what builds strong memories and genuine understanding. Just copying, way less learning happens. It feels easy, but it's less effective.
So the key takeaway is?
Use AI to guide you, to help you structure your thoughts, maybe suggest avenues to explore, act as a sparring partner. But don't let it do the thinking for you. You know, the old saying about university being about learning how to think, not just finding answers. That applies perfectly here. True for any learning, really.
That's such a critical point. So, wow, we've covered a lot of ground today, really taking that deep dive into generative AI. We started with the core definitions, how it's different from predictive AI. We looked under the hood at neural networks, transformers, key terms like parameters, context windows.
And we explored the real world side too. Those reasoning models, how developers actually use APIs, the whole open versus closed debate, and essential platforms like Hugging Face.
And most importantly, hopefully, we've given you some ideas on how to use this powerful tech to boost your own learning, but also that crucial warning about staying actively engaged.
Yeah, the potential of Gen AI is just immense, creating new things, helping us reason through complex problems. It's incredible. But its real value, especially for personal growth, comes from that thoughtful, active engagement. Use it to amplify your own brain, not switch it off. Work smarter, not just outsource the effort.
Absolutely. And that leaves us with maybe one final provocative thought for you to mull over. We talked about reasoning models getting better at thinking before they answer, generating those internal chains of thought. So consider this. If these models get really good at that, how might that fundamentally change what we even mean by understanding? Not just for us humans, but for the AI itself. What does it mean for an AI to understand if it can simulate reasoning so convincingly?
That's a deep one. Definitely something to think about.
It is indeed. We really encourage you to keep exploring these ideas, maybe check out some of the models or platforms we mentioned. Thanks so much for joining us for this deep dive.